Good morning, students. Today we are going to see the second subtopic of Unit 2, Observed Effects of Climate Changes, Patterns for Variable Large-Scale Variability. Introduction to large-scale climate variability. So, the variability, climate changes has been in a larger scale. Climate change involves more than a gradual rise in global average temperature. So when we say is a climate change occurs, when there is a gradual rise in global average temperature, then we say is a climate change. The climate change is found to be around 1.8 degrees Celsius increase in every year because of the urbanization as well as the industrialization. Okay, it also affects large scale circulation pattern in the atmosphere and oceans. That means the surface water is getting heated up. Obviously, there will be heat transfer. Because of the heat transfer, um, the because ENSO events will occur, that El Nino and La Nino events, which we have seen in the last class. This shift drive regional weather extremes and changes in hydrological system worldwide. So weather extremes, this shift drive the regional weather extremes and changes in hydrological system worldwide. That means some region will be flooded, some region will be drought, and so and things like that. All right. Understanding this pattern is key to predicting impact on water resources, agriculture, and ecosystems. Understanding this pattern is key to predict the impact on water resources. So whether if it is flooded, how to go about it, okay, and if it is drought, how to go about it, impact on water resources, agriculture, as well as the ecosystem, how the ecosystem, including the marine life, is getting affected. Okay, we are not only the species on the planet. Okay, we have plants, we have what do you call them, animals, okay, reptiles, even marine lives are there. Okay, so this is all included as the ecosystem. Such patterns can intensify the drought, flood, and seasonal variability with global socio-economic implications. Global surface temperature trend. So, the global average surface temperature, including land air temperature and sea surface temperature, has risen steadily since 1861. Before industrialization, okay, because of the human made activities, okay, when it is, since it has been started yearly around 1861, it has been found that there is a steep increase in the not only the seawater temperature, sea surface temperature, but also the land air temperature. Two short warming phases occurred in 1910 to 1940 and 1980 to 1990. This we have discussed already. While averages are important, extremes in heating and cooling often have greater real world impact. So, heating and cooling often have greater real world impact. If it is getting heated up or if it is cooled down, again is a greater real world impact. These extremes can disturb the agriculture, energy system, and public health far more than the gradual temperature shift. What is ITC? Is it intertropical convergence zone? Okay, is a major heat source that drives atmospheric circulation. Earlier theories suggested that ITC is at displacement caused Shaolin drought, but rainfall data did not confirm the hypothesis. So it's a theory that we don't have any proof for that. Okay, that's what they mean. Persistent drought since 1968 has shifted isohydrate southward in Africa. Changes in surface temperature of sea, that is sea surface temperature, SST, in surrounding oceans are considered possible drivers of the Chagall's prolonged aridity. Asian Australian monsoon system influences the climate of over 60% of the world population. So what is this Asian Australian monsoon? Okay, so it's a monsoon period which influences the climate of over 60% of the world population. So Asia and Australia covers almost 60% of the world population. So the world population is almost, it has been 7 to 8 billions. Okay, 700 to 800 crores. Okay, that is a population. Just imagine 60% of the population lives in the Asia and Australia. Indian summer monsoon brings almost most rainfall between July and September, crucial for agriculture. Year to year variability affects crop yields, water supply, and economy. While no significant long-term ISMR trend is evident, regional increases and decreases exist. Global models struggle to accurately replicate monsoon precipitation patterns. Global models struggle to accurately predict the monsoon precipitation. So the model will help you to identify how much is the rainfall which may occur during this particular monsoon on this particular area. Okay, it's very difficult to predict it. That's what they mean. Monsoon depression under cyclones, the frequency of monsoon depression in India dropped by 50% over the 20th century. Okay, so the depression in India dropped by 50%. Low pressure areas have increased since the 1960s, but conditions have been less favorable for intensification into depression. Cyclonic storm frequency in May, October, and November shows a rising trend, especially in November. These changes may link to broader atmospheric and ozonic circulation shift. So I can say some 20 years or 30 years back or 40 years back, yeah, 10 years once you will find a cyclone. But now it's become very common. 2 years or 3 years, the cyclone comes. Okay. So cyclone storm frequency in May, October, November shows a rising trend, especially in November. These changes may link to broader atmospheric and ozonic circulation shift. So how the cyclone occurs? Because of the low pressure which has been formed in the seashore, right? So in the sea, so that will when it crosses the land, it will come with the high speed and then it will crash, right? So these changes may link a broader atmospheric and ozonic circulation shift. Cyclones in the Bay of Bengal. Okay, so when I was during my childhood in 1992, there was a heavy cyclone. Okay, there is a two cyclone which happened. There is a gap between the two cyclone. Okay, after the cyclone was over, the people thought it was over, so they want to go and look into the sea. So most of the people have went there. Okay, suddenly what happens after 10 minutes or 15 minutes, the next cyclone came. So even the radar station was very close to us. Okay, but the what do you call it, the that time the people done they don't have that awareness. After the cyclone completes, they thought actually there won't be any other cyclone comes, right? So what happened within a 10 minutes another cyclone come. Many people who went to see actually after the cyclone, what happened, they have been affected and they have died, most of them. Okay, so the Bay of Bengal experienced a seasonal peak in cyclone activity, particularly in May and November. Climate variability affects cyclone intensity, path, and rainfall pattern. Rising surface temperature are believed to enhance the cyclone potential energy. Underline the word cyclone potential energy. Rising sea surface temperature are believed to enhance the cyclone potential energy. So the potential of the cyclone is increases. That means the speed will be more, and the effect of the human on the living species or the people who are living very close to the coastal region will prone to affect. Okay, we will have a higher intensity of disaster. Okay, so coastal communities face increased flooding and storm surge risk during this month. Enhanced disaster preparedness is essential for minimizing the damage and loss of life. Because of radar and because of the satellite things, okay, the people could be able to predict the heavy rainfall as well as the cyclone. So because of that, what they do, they could be able to take a precautionary measures. Okay, so in order to avoid, they will avoid the maximum damage. But however, there will be minimum damage definitely will be there. Okay, tropical cyclones and warming oceans. Warmer oceans provide more latent heat, fueling stronger tropical cyclones. Observations suggest an increase in the number of intense cyclones in recent days. Changes in vertical wind shear and atmospheric moisture also influence the cyclone development. Such shift may alter cyclone track, affecting previously safe coastal areas. These are direct implication for agriculture, infrastructure, and human settlement. Tropical cyclone and warming oceans. Okay, they have a direct impact excuse me, for agriculture, infrastructure, and human settlement. El Nino. So in the ENSO events that we have seen what is El Nino and El Nino and the difference between these two and what is the neutral conditions. Okay, how the flow takes place on the sea surface. This is all we have seen. We will quickly go through it this again. ENSO is the most significant mode of interannual climate variability impacting weather worldwide. It consists of warm El Nino and cool La Nino phases driven by specific ocean atmosphere interactions. El Nino often weakens the monsoon rains in India, leading to drought. La Nino can enhance the monsoon strength but may cause floods in some regions. ENSO forecasting is vital for agriculture planning and disaster risk reduction. What is the El Nino characteristics? El Nino involves abnormal warming of central and eastern tropical Pacific Ocean waters. It disrupts the normal trade wind patterns, weakening upwelling in coastal Peru and Ecuador. Global effects include drought in Australia, Indonesia, and India. Global effects include drought in Australia, India, and Indonesia, and flood in South America. Because these are the characteristics of El Nino. So, what are the effects of El Nino? El Nino events typically last 9 to 12 months, but strong one can persist even longer. Historical data shows a recurring pattern every 2 to 7 years. So, what are the characteristics of La Nino? La Nino is the opposite phase of El Nino, marked by cooler than average Pacific waters. It strengthens trade winds and upwelling, enhancing the rainfall in Southeast Asia and Australia. So it strengthens the trade wind, okay, and enhance the rainfall in the region of Australia and Southeast Asia. India often experiences the above average monsoon rain during La Nino years. However, excessive rains may lead to floods and landslides. So El Nino or La Nino, how the direction of wind takes place, okay, how the heat transfer takes place from this equator or to the Arctic or from the Arctic to the equator. Just go and refer back the things which we have taught in the unit 1. However, excessive rains may lead to floods and landslides. Like El Nino, La Nino also recurs every 2 to 7 years with varying intensity. ENSO and Indian monsoon link. Historical data reveals a strong correlation between ENSO phases and Indian monsoon rainfall. El Nino years tend to produce deficient rainfall and drought in India. La Nino years often bring abundant rain, sometimes causing floods. However, recent studies suggest climate change may weaken this link. Accurate ENSO prediction helps optimize the agriculture cycle and water management. Coming to the specific decadal oxidation. What is specific decadal oxidation? Any idea what is specific decadal oxidation? Specific decadal oxidation is a long-term ozone fluctuation in the Pacific lasting 20 to 30 years per phase. Okay, it is a long-term fluctuation of the Pacific Ocean climate. Okay, it is a long-term fluctuation of Pacific Ocean climate characterized by variation in sea surface temperature and atmospheric conditions with a cycle of roughly 20 to 30 years. Is similar to El Nino southern oscillation but with a much longer time scale. The PDO, that is Pacific Decadal Oscillation, Pacific Decadal Oscillation, has distinct warm and cool phases influencing weather patterns and potentially impacting global climate, particularly in the North Pacific. So the duration PDO cycles typically last for 20 to 30 years, significantly longer than ENSO events, which usually last for 6 to 18 months. The PDO has two main phases. One is positive phase, another one is negative phase. They are also known as warm phase and cool phase. During the warm phase, that is positive phase, warmer than average sea surface temperature in the central and eastern North Pacific and cooler temperature in the western Pacific. Whereas the cooler phase, that is the negative phase, cooler than average sea surface temperature in the central and the eastern North Pacific and warmer temperature in the western Pacific. So what is the impact of PDO? So PDO has three impacts mainly. Okay, can affect weather patterns and climate, influencing factors like global weather, regional climate, and as well as the ozonic conditions. Okay, what is global weather? Changes in the PDO can alter the jet stream, impacting the storm tracks across the United States. Regional climate impact vary by region with potential effect on temperature, precipitation and even agricultural and fisheries patterns. Ozonic conditions. The PDO influences sea surface temperatures and currents affecting marine ecosystems. So the positive PDO often enhances El Nino impact while negative PDO strengthens the La Nino effects. The PDO is a Pacific decadal acceleration phases affect fisheries, agriculture, and regional climate planning. Monitoring PDO is a key for understanding the decadal climate trends. Indian Ocean Dipole, which we have seen in the last class, okay, is a climate pattern in the Indian Ocean with positive and negative phases as that of the previous case. That is, as that of the previous case, what is a Pacific decadal oxidation. And positive IOD, that is Indian Ocean Dipole, brings warmer water to the Western Indian Ocean, increasing the East African rainfall. Negative IOD causes opposite effects, reducing rainfall in Africa but increasing it in the Indonesia. IOD, that is Indian Ocean Dipole, significantly interacts with the ENSO events, influencing Indian monsoon behavior. So forecasting the IOD phases aids in drought and flood preparedness. So here the Pacific decadal oscillation have a positive phase and negative effect. Similarly, here also you have a positive IOD and negative IOD, Indian Ocean Dipole. North Atlantic oscillation. So what is North Atlantic oscillation? It is a pressure difference between the Iceland and the Azores influencing Europe and North African climate. Positive. Again, the positive and negative phases are here. Okay, the positive North Atlantic oscillation strengthens the westerly winds, bringing mild, wet winters to Europe. Negative NAO, that is North Atlantic oscillation, negative, leads to a colder, drier conditions. NAO also indirectly impact Asian monsoons via atmospheric teleconnections. It is a key driver of seasonal weather variability in the northern hemisphere. Arctic oscillation is a climate pattern characterized by winds circulating counterclockwise around the Arctic. Positive AO traps cold air in the polar region, leading to milder winters in mid latitudes. Negative AO allows cold Arctic air to spill southward, causing severe winters. And Arctic oscillation shifts influence snow cover, sea ice extent, and storm tracks. It increasingly studied in the context of Arctic warming. So, what is mean understood actually? This all this AO, NAO, IOD, and PDO. It talks about the oscillation. Okay, the how the wind pattern affects the what are the regions, whether it's give a positive effect or the negative effect. They used to say, okay, because of that, whether the flooding takes place or it become dried and so on and so forth. Okay, so don't need to memorize all this. What you need to do, please try to understand the concept. Just draw a map, geographical map. Just take a thing and see where this movement, dipole movement, or Indian dipole movement, or previously the Arctic. Okay, so Arctic oscillation. This all you just note it down in that particular region. If it is positive, negative, what is the effect on that? How the circulation of air takes place, that you need to know. So when come to the median Julian oscillation, median Julian oscillation is a tropical disturbance that travels eastward around the globe in 30 to 60 days. It modulates rainfall in the tropic, can influence cyclone development. So this oscillation can also influence the cyclone development. Active NGO phases enhance convection, boosting monsoon rains in South Asia. MJO can cause affect the ENSO events by altering the wind and ozone conditions. So, main Julian oscillation also affect the ENSO events. The ENSO events are El Nino and La Nino. Okay, by altering the wind and ozone condition. Understanding the Madden Julian oscillation improves medium range weather forecast. Climate variability versus climate change. Climate variability refer to short to medium term fluctuations in climate pattern. Climate change is a long term trend. Okay, climate change is a long term trend. Climate variability is a short, refers to a short to medium term fluctuation. Is a long term trend. Climate change is a long term trend. That's the difference between the climate variability and climate change. Often, climate change often driven by greenhouse gas emissions. Both interact making prediction complex. Variability can mask or amplify the climate change impacts in the short term. Policymakers must account for both to develop the resilient adaptation strategies. Impact on water resources. Shift in large-scale climate pattern alter the rainfall distribution and intensity. Drought-prone regions may become drier, while flood-prone areas may see increased rainfall. Seasonal water availability affects agriculture, hydropower, and drinking water supply. So, seasonal water very availability. For example, if you have a hydropower plant, that means based on the water you just have a electricity has been produced, okay, or drinking water supply or the agriculture is all, if there is any scarcity of water, what will happen, all will get affected, right? Agriculture will get affected, drinking water supply, scarcity of water will happen, and hydropower electricity production will be low. So the seasonal water availability affects all this. Glacial melt rates are influenced by warming and atmospheric circulation changes. Integrated water management is essential under changing climate regimes. Impact on agriculture. Climate variability affects planting seasons, crop yields, and pest outbreaks. El Nino related droughts can devastate rained agriculture in Asia and Africa. La Nino linked floods may destroy crops and reduce the food security. So, this La Nino effect floods may destroy the crops, okay, and also reduce the food security. So, if there any scarcity of, again, the flood is in, food is insufficient, okay, reduce food security, food would be insufficient, the people will be affected. Even if the flood is more, or the crops may be affected, okay, the crops are affected, obviously the food consumption, I mean the food requirement will be increased, so we could not able to fulfill the requirement of the humans. Okay, farmers can adapt by using the climate forecast to adjust the crop choices. Okay, farmers can adapt by using the climate forecast to adjust the crop choices, as I told you in the previous class. So if they know actually this is a rainy period or something, based on that, they will go for the crops. Or if there is very summer and they found that there won't be any rain, obviously they will choose a particular type of crop that doesn't require a large quantity of water. Okay, agriculture resilience depends on better weather prediction and irrigation management. Impact on energy systems. Hydropower generation depends heavily on river flow influenced by rainfall pattern. So if there is no rainfall, if it is a drought, what will happen? The river will shrink. That means river there won't be any much river flow. Obviously, that will affect the hydropower generation, electricity generation by means of hydropower. Okay, drought reduces hydropower capacity, increasing the reliance on fossil fuels. Then we need to go for again fossil fuels, that will help you to produce the electricity. Okay, by means of burning the coal or by means of what you call the, okay, fossil fuel. Okay, they will convert the, they will eat up the things and then try to produce the steam. The steam will help you to run the turbine, and from the turbine which that will be connected to generator, and then electricity will be produced. That you know already, right? Heat waves can lower the thermal power efficiency and strain electricity grids. Wind and solar output are also linked to climatic variability. Climate smart energy planning is essential for future sustainability. Impact on ecosystems. Shifting rainfall and temperature patterns affect species distribution and migration. Coral reefs suffer bleaching during prolonged warm water events. Coral reefs suffer bleaching during prolonged warm water events. So during the warm water events, coral reefs suffer bleaching. So meaning to say, the coral reefs which are present under the earth, okay, as I told you in the previous lecture, okay, the scuba diving people will shoot the coral reefs. Okay, it looks like very greenery, and it will like what you call the flying plantations, plants, right? But the coral reefs, okay, which is not getting affected. Otherwise, it will affect the marine life. Okay, wetland ecosystems may dry out or flood, altering the biodiversity. Forests face increased fire risk under drier condition. So, if it is very dry, what will happen? There is forest can make take a catch up fire. Okay, so forest face increased fire risk under drier condition. Protecting ecosystem requires integrating the climate projection into conservation strategies. Human health implication. What are the human effects? How it affects the the climate change, large scale climate variability, how it affects the human health. Human health implications: heat waves increase heat related illness and mortality rate. Okay, heat waves, when the hot stroke may occur, which I told you in the last class also, right? The floods can spread waterborne diseases like cholera. If it is flooded, obviously there will be a lot of flood related diseases may spread like cholera. Drought can lead to malnutrition through reduced food availability. So the drought will affect the crop cultivation. The crop, if it is less, obviously the food scarcity may occur. Because of that, the people, the people, including the children, will have a malnutrition. So most of the videos you might have seen actually because of in South Africa, right? Continent. Vector-borne diseases like malaria may expand into new areas. Public health planning must consider climate-related risk. Disaster risk reduction. Understanding the climate variability improves disaster preparedness. Yearly warning systems for droughts, floods, and cyclones save lives. Infrastructure must be designed for changing the climate streams. Okay, infrastructure must be designed for changing the climate streams. Okay, the greenhouse building. Okay, the people nowadays they have a greenhouse thing. So, what is the greenhouse in the sense? The proper ventilation will be there. They don't use the lights actually during the daytime. There won't be any air conditioner is required because it has been constructed in such a way that on either side they will have a pond like small pond or the swimming pool, so that when the breeze comes, okay, they depending on the wind direction only they will construct the houses or greenhouse building, so that if the nearby any water pool is there, obviously you get a chill air, so you don't require any air conditioner. So these all try to reduce the consumption or conserve the energy, okay, so that there won't be any increase in the greenhouse gas emission. Okay, so the infrastructure must be designed for changing the climate extremes. Community awareness and training enhance resilience. International cooperation strengthen the response capacity to climate disasters. Role of climate models. Climate models stimulate interaction between the atmosphere, ozones, and land. They help project future scenarios based on greenhouse gas emissions. High resolution models improve the regional climate predictions. Limitation remain due to uncertainties in data and model physics. Continuous model refinement is essential for accurate forecasting. So, but finding a forecasting for regional areas or in a large scale is not easy. Okay, so it may the hypothesis they have, okay, may valid or may not valid, or accuracy is not very 100% true. Okay, these are the constraints we used to have. The role of climate models. Okay, the climate models stimulate the interaction between the atmosphere and ozone layers. They help project the future scenarios based on the greenhouse gas emission. Coming to conclusion, large-scale climate variability significantly influences weather, ecosystem, and Human system. Whether it is a large-scale climate variability or a climate change, okay, they continually affect the weather, ecosystem, and human systems. Understanding the ENSO, IOD, PDO, and INOVO and other patterns improve the resilience. Climate models and forecasts support informed decision making. Okay, adaptation strategies must integrate both variability and long-term change. Global cooperation is important to mitigate the and adapt to the climate impact. So, the large-scale variability, what are the influence? It affects the weather, ecosystem, and human systems. So, hope you understood today's lecture. It will be beneficial for you, I believe. Okay, the understanding the patterns of wind patterns and the positive phase and negative phase of um, uh, what do you call it, the Indian dipole, dipole and Pacific things. Okay, and so IOD, PDO, and NOO, the positive phase and negative phase. Hope you will understand in today's lecture. If you have any doubt, please come during face-to-face section, which will be um, day three and day two, day three and day four. Okay, that definitely you will get benefited. If you have any doubt, just come and meet me around 3:15 to 4:15. Okay, so that is a regular class, right? Okay, please come on the regular class. Apart from that, if you have any doubt, any other time also, you are most welcome. Okay, so we will, if you have any doubt, just note it down in face-to-face section. When you come, I will clarify your doubts. Okay, this is all theory. So what you need to do is that just take a graph, segregate, separate different parts, hemisphere, semi, what do you call, north direction, west direction, how it looks like. Okay, Arctic, Antarctic, northwest direction, how the flow takes place, what is the dipole movement, and things like that. Okay, this all you supposed to, I mean, you're supposed to know. Okay, IOD, what dipole, what I mean is the IOD. Okay, so and things like that. So I stop it here. We'll see in next class.